All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our corrective measures module. Let's have a look at what we went over today. We're going to dive right in. First and foremost, let me get that compiling immediately, and then we're going to pick up on our reading. So to get that start compiling, then we're going to start with the reading. All right, so at this point, we're taking some creative measures, and our model is performing better. Next, we will look at how to load our model even faster and more efficiently. This can be done using the TensorFlow Data API. For this, we'll be looking at the tf.data function. Inside the tf.data overview, we will be using the tf.data.dataset. The tf.data.dataset function represents a potentially large set of elements. This class is made of many methods, so we will be starting with the from TensorFlow slices method. So from here, we will adapt our code to use TensorFlow's data API in order for us to gain from all the advantages that come with it. Now note that when we're working with a data set of, let's say, 1,000 elements, we wouldn't clearly notice the advantage of using this data API. But as our data sets get larger, it is very important to master how to use this API. With that said, we're going to redefine our X train. So here, we're going to say train data set, and we're going to have tf.data.dataset from TensorFlow slices. Next, we're going to create a tuple, and then we will pass in our X train and Y train. And let me give you a look at what that looks like here. So that's this here. Train dataset equals tf.data.dataset.from tensor slices X train Y train. Now that we got this, the next thing we're going to do is we're going to shuffle our dataset. Now we've already done shuffling, but in the case of where shuffling hasn't done previously, we can do the shuffling very easily now. Let me get ahead and get this clear out the way so we can finish compiling first. Okay. Okay, so here we have train dataset dot shuffle, and we specify a buffer size of, let's say, 8. And let's see exactly what this buffer size actually means. For instance, if our data set contains 10,000 elements, but buffer size is only 1,000, then Shuffle will initially select a random element from only the first 1,000 elements in the buffer. Once an element is selected, its space in the buffer is replaced by the next, i.e., 1,001st element, maintaining the 1,000 element buffer. Also inside our shuffle function, we will add a reshuffle each iteration by setting the parameter to true. So let me give you a look at what that looks like. One second, where is that? Let me actually take you to the data preparation and show you so I don't have to go through all of the reading and show you. So that's this here. So you see here we have our reshuffle, each iteration equals true. Then we also added a batch size of 32 because we wanted to batch our data. And then we added a prefetch. And then the parameter for prefetch was tf.data.auto. Now let me go back over here so I can explain what that is. Yeah, that's the true right there. That's the batch size. With that done, next we will have our training set batch by size 32. Okay, let me get these second set of plots out the way. Okay, and from here we will do prefetching. Prefetching creates a data set that prefetches elements from its data set. Also, we are told that this allows later elements to be prepared while the current element is being processed. So all that means is that while one element is being processed, we can actually go ahead and start preparing another element to be processed as soon as the one we're processing is done. That's all the prefetching means. And this is how it's going to look like when we add it all together. So we have our train data set equals train data set dot shuffle, buffer size equals 8, reshuffle each iteration equals true, and then we have our batch size of 32, and then we have our prefetch. And we're going to set that to auto tune. So that means the algorithm is going to take care of it for us so we don't have to specify exactly which element we want to prefetch. It's going to select where it's going to prefetch on its own. So now we have a training data set. Let me get this out the way. And next we will add this and run it to batch our data set. So first we're going to batch our data set once we get this plot out the way. And we're going to use it for XY in training data set. And we're going to print XY so we can print X and Y separately. And then with all of that done, our data set is ready to be trained. So all of that was done so we can batch our data set. And this is the outcome here. So you can see our data set is now batched. This is it here, tf.tensor. And you can see all of this is batched up now in a batch size of 32. Let me show you the shape of it so you can see. So you can see we have a shape of 32 by 8. So our batch size is 32, And then we have a buffer size of 8, as you can see here. So you can see our buffer size of 8, batch 32, and you can see that's the shape of our new data set. So we have 32 and 8. So we are going to go ahead and train this new data that we have formatted, but we're not going to do that today because it was already a lot, and I am running kind of behind on time because I was doing a lot of things this morning, but we actually got it done and we got it knocked out the way. But of course, I'm going to keep you posted every step of the way. For now, you guys stay Gucci. It's the Python Papi.